So, you've decided to buy a pair of passive hi-fi speakers. You've done your research, you've got yourself a media player and an amplifier, you're ready to rock. But what's behind the music? How do your speakers actually work? Let's take the same journey your audio signal does. Every speaker needs terminals to let the audio signal in. They come in pairs. A positive and negative current is needed for the cones and tweeter to vibrate back and forth. This push-pull of voltage is what we call alternating current, or AC. The terminals are made from conductive metals such as copper or gold, and are themselves wired to the brains of the operation, the crossover. In the case of MIT-50, the crossover is mounted directly on the back of the terminal plate. We'll look at that now. The crossover is the gatekeeper. It separates the incoming signal into frequency ranges tailored to the speaker drivers, the cones and tweeters that produce the physical sound. Bass goes to the woofers, the mid-range goes to the mid-range drivers, and the treble goes to the tweeter. It works by using components called capacitors, inductors and resistors to cut some frequencies and let others through, depending on which driver they're meant for. This cutting and passing is literally the language we use to describe what's happening. High cut will shave some of the higher frequencies off an audio signal, and a high pass will allow more of them through. It usually happens gradually. We call this a slope. Let's look at the speaker drivers themselves. It's important to split the signal like this because drivers are designed for certain frequency ranges. A woofer is big because it moves a lot of air. It might be made of heavier material to give it more air pushing power, because it doesn't need to move back and forth more than around 500 times a second. A tweeter needs to move back and forth more than 20,000 times a second, so small and light is the way to go. Let's get a bit sciencey now. But don't worry, we'll keep it brief. At the heart of a speaker driver is its voice coil. It's a spool of highly conductive metal, like aluminium wire, wrapped around a hollow cylinder we call a voice coil former. It's attached directly to the back of the speaker cone, so when the voice coil moves back and forth, so does the cone. That moves the air in front of the cone back and forth, creating the sound waves you hear. If you pass an electrical current through a coil of wire, it generates an electromagnetic field. You might have made something like this with a battery and some wire at school to pick up paper clips. It's the same principle. If this electromagnet is surrounded by a larger, heavier permanent magnetic field, it's attracted and repelled as its polarity changes back and forth between positive and negative, exactly in line with the frequency and intensity of the signal coming from the amplifier. In other words, it moves back and forth with the pitch and volume of the music, and because it's attached to the back of the cone, that moves too. And then so does the air, and, well, you get it. Simple. Around the outside of the cone is a surround, and at its center the spider. These two elements are highly flexible membranes that let the cone and the voice coil move freely, but not too freely. They keep everything from going haywire. When we're building speaker drivers, we experiment with a massive amount of materials and designs, then listen to the results to make sure they're putting out what went in from the amplifier. So now you know how an audio signal gets from your amp to your ears. Lots of wire, magnets, and high quality wiggly air. Thanks for watching.